Hello everyone, welcome to our presentation on Cartesian coordinates for the course Math 161. Today we will briefly introduce and talk about the basic topics of this chapter. I am Raiyan and alongside me is Sudipta. Without further delay, let us review our table of contents. We have coordinate system, Cartesian and polar coordinate system, transformation of coordinate system, orthogonal curvilinear coordinates, spherical, polar, and cylindrical coordinates, and the change of axis. First topic is the coordinate system. So what exactly is a coordinate system? A coordinate system is a method used to uniquely identify the position of points in space using numbers known as coordinates. We primarily have three kinds of coordinate systems, such as the one-dimensional, the two-dimensional, and the three-dimensional coordinate systems. We have learned the formal definition. Now let us get a better understanding through demonstration. Let's say we want to point out the locations of some objects in a one-dimensional space. For that, we have to define an origin, which is the reference point of our coordinate system. Then we can define those points with respect to the origin. For example, we may wish to describe the locations of some students of our university. They are denoted by letters from A to I. In order to describe their locations accurately, let us consider the 0 point of our campus as the origin. Now their positions can be described by the distance from the 0 point. Two-dimensional coordinate systems. The most common case is the Cartesian coordinate system. Here we can describe the position of an object in two dimensions by specifying two numbers. For that, we have to define two axes x and y with origin and direction. And the x and y axes are perpendicular to each other and share a common origin. And the x and y axes divide the two-dimensional xy plane into four quadrants. For the first quadrant, both x and y are positive. And for the second quadrant, y is positive while x is negative. And for the third quadrant, both x and y is negative. And for the fourth quadrant, y is negative and x is positive. So what is the Cartesian system? The plane is called the Cartesian or coordinate plane, and the two lines x and y when put together are called the coordinate axes of the system. The two coordinate axes divide the plane into four parts called quadrants. The intersection point of the axis is the zero of the Cartesian system. This point will generally be denoted by O. The coordinates of the origin are denoted as 0, 0. The distance between two points x1, y1 and x2, y2 in Cartesian coordinate systems can be found out using the formula. What is the polar system? A coordinate system where the position of a point is determined by the distance from a fixed point or origin and the angle from a fixed direction. Often used in scenarios involving circular or rotational symmetry, such as in physics, engineering, and navigation. The distance between two points in polar coordinate systems can be found out using this formula. So how can we convert between Cartesian and polar coordinates? First, let us take a Cartesian coordinate. Here we are taking the x and y axis and pointing out a point. Let it be x and y. Now from the origin, let us take a straight line. This is r, and the angle it creates with the x-axis is the theta. So r is equal to square root of x squared plus y squared, and theta is the inverse function of tangent of y over x. Using this formula, we can go from Cartesian coordinates to polar coordinates, and using the formulas from x equals r cos theta and y equals r sin theta, we can go from polar to Cartesian coordinates. Now moving on to 3D coordinate systems. In 3 dimensions, we need to specify 3 numbers to describe the position of an object. In 3-dimensional Cartesian coordinate system, we simply add a third axis, the z-axis, that is mutually perpendicular to both the x-axis and the y-axis. Two additional coordinate systems are common in three-dimensional coordinate systems. They are cylindrical coordinate system and the spherical coordinate system. Moving on to orthogonal curvilinear coordinates. Here the coordinate surfaces intersect at right angles, which means the lines are mutually perpendicular. It helps with calculations in certain geometries, such as it is often used in physics and engineering to simplify problems involving curved surfaces, such as cylindrical and spherical coordinates. We can use the equations below to calculate these types of problems. Now moving on to cylindrical coordinates. Cylindrical coordinates can be thought of as an extension to the polar coordinates. Here phi, which is the angle between the x-axis and the line from the origin to the projection of the point in the xy plane. The radius rho, which is the distance between the point and the z-axis. So the point P can be denoted as P, R, phi and z. Here x equals r cos phi, y equals r sin phi and z is equal to z. Spherical coordinates. In spherical coordinates, a point P is described by the radius r, the polar angle theta and the azimuthal angle phi. The radius is the distance between the point and the origin. The polar angle is the angle with the z-axis that is made by the line from the origin to the point. Note that the value of phi must be between 0 and 2 pi, whereas the value of theta must be between 0 and pi. So the point can be denoted by P, R, theta, phi, where x equals r sin theta cos phi, y equals r cos theta sin phi, and z equals z cos theta. What are elementary quantities in coordinate systems? It typically refers to the basic measurements that can be represented using coordinates such as position, distance, direction. It is fundamental for defining points and shapes in a given space. To the change of axis. The change of axis in a coordinate geometry refers to the transformation from one coordinate system to another, which can involve translation, rotation, and combining both translation and rotation. What is the translation of axis? It refers to the shifting of the original coordinate system to a new one, where the new axes are parallel to the original axis but are displaced by certain units horizontally and vertically, so that x becomes x prime and x prime equals x minus x naught, and y becomes y prime, where y prime equals y minus y naught. And moving on to the rotation of the axis. Here we are changing the orientation of the coordinate system by rotating the x and y axis around the origin through a specified angle. So x becomes x prime and x prime equals x cos theta minus y sin theta, and y becomes y prime. So y prime equals x sin theta plus y cos theta.